All right, deep divers, welcome back. Today we're going to try to figure out something pretty cool. What's the connection questions actually get answered?
Yeah.
Like how are artificial intelligence and machine learning connected?
Hmm.
The source material we dug up is really fascinating. It's code snippets and explanations that actually break down the process step by step.
Wow.
And to get this, we're even going to get a glimpse of a specialized language called KickLang.
How cool.
It's like the
Well,
secret sauce for unlocking these connections.
what's really interesting about this whole thing is that it's not just about finding a simple link between two things.
Right.
It's about understanding this complex web of relationships that connect all these different ideas and concepts.
Okay.
So think of it like you're not just asking, is there a connection?
Yeah.
You're really trying to understand what kind of connection is it?
Mm.
How strong is it? And how does it fit into the bigger picture?
Yeah. Okay, so we're not just skimming the surface here. We're going deep. And to navigate this intricate web of knowledge, we need like a guide, a map, a decoder ring. And that's where KickLang comes in, right?
Exactly. Imagine you ask, what is the relationship between artificial intelligence and machine learning?
Okay.
Well, KickLang takes that question and transforms it into a precise code, something like artificial intelligence machine learning. And this isn't just a simple translation, it's distilling that query into its purest, most logical form.
So KickLang is like the Rosetta Stone for knowledge graphs.
Hmm.
But why do we need this special language? Can't we just use plain English?
Well, natural language is nuanced and complex, It's full of ambiguities and these subtle meanings that can trip up even the most sophisticated algorithms.
Yeah.
But KickLang, on the other hand, it's designed specifically for querying knowledge graphs. It's precise, it's unambiguous, and it's structured in a way that machines can easily understand.
So it's like having a secret handshake that grants you access to this vast network of information. Okay, I'm starting to get the picture. It's like we need a special key to unlock this treasure chest of knowledge. So let's crack this chest open and see what's inside. Our sources outline 4 key steps in processing these relationship queries. And it all starts with step 1, translation. Now, we've talked about this a little bit, but I'm curious, what are some of the challenges involved in translating natural language to KickLang?
That's where the real magic happens. This whole field of natural language processing is incredibly complex.
Yeah.
Just think about all the different ways we can phrase the same question,
Sure.
all the idioms and colloquialisms we use,
Yeah.
and all those unspoken assumptions that underlie how we communicate.
Right.
Translating all of that into a precise machine-readable format is a huge challenge.
Mm-hmm.
It involves things like parsing sentence structure, identifying those key entities, and resolving any ambiguities.
It sounds like building a bridge between 2 completely different worlds. That messy, nuanced world of human language and then the precise, logical world of machines.
Exactly. And the success of that bridge really hinges on the sophistication of that NLP model.
Okay.
A basic model, it might just look for keywords, simple patterns.
Uh,
But a more advanced model can actually try to understand the intent behind your query. It takes into account context, semantics, even common sense reasoning.
so the quality of the translation is crucial for getting accurate results.
It's sense. Let's move on to step 2, knowledge graph interaction.
Hmm.
So once our query has been transformed into KickLang, it's sent off to the knowledge graph. What happens next? I'm picturing this vast digital landscape with all these nodes representing concepts and links representing relationships. Am I on the right track?
You're spot on. The knowledge graph is like a giant web of interconnected information that's constantly growing and evolving. But it's not just about storing all these facts. It's really about representing the relationships between those facts.
And those relationships can be incredibly complex. We're talking about hierarchies, dependencies, influences, contradictions, a whole symphony of connections that shape our understanding of the world.
Wow, that's a powerful image. So when our KickLang query arrives, it's like sending a spider out to crawl this web, searching for those specific connections we're looking for. But how does the system actually navigate this massive network? What are some of the technical challenges involved in this knowledge graph interaction?
That's where things get really interesting. Knowledge graphs can be incredibly large, with billions of nodes and trillions of links.
Wow.
So finding the right path through this labyrinth requires sophisticated algorithms and data structures. Think about it like this. If you were searching a library, you wouldn't flip through every single book, right?
Right.
You'd use the card catalog, the index, the Dewey Decimal System, tools that help you pinpoint the exact information you need.
So the system needs a way to efficiently search and retrieve the relevant information without getting lost in this maze, like
Yeah.
its own knowledge graph GPS.
Precisely. And there are so many fascinating challenges involved in designing those search and retrieval systems.
Okay.
For example, how do you handle queries that involve multiple hops through the graph?
Hmm.
How do you deal with incomplete or contradictory information?
Right.
And how do you ensure that the results are actually relevant and accurate and presented in a way that, humans can understand?
This is getting me really excited. We're starting to see the complexity and ingenuity behind these systems.
Uh-huh.
Okay, so we've translated our query, sent it off to the knowledge graph, and hopefully retrieved the relevant information. What happens in step 3? Relationship analysis and presentation.
Mm.
I'm guessing this is where the system really starts to flex its analytical muscles.
You're right on track. This is where we take that raw data and transform it into meaningful insights. Remember, we're not just looking for a simple yes or no answer here.
Yeah.
We want to understand the nature of the relationship, the nuances, the context.
So it's like the system is playing detective, piecing together the clues to reveal the hidden story behind that connection.
Exactly. And the code has to do a lot of heavy lifting here.
Oh, I bet.
It needs to analyze the retrieved data, identify patterns, and classify the relationship based on predefined categories. For example, is it a causal relationship, a hierarchical relationship,
Right.
or maybe a correlational relationship?
Hmm.
And how strong is the connection? Is it a direct link, or are there some intermediary steps?
It sounds like a fascinating blend of data science, linguistics, and even a bit of philosophy.
Absolutely. And the way those results are presented is just as important as the analysis itself. Remember, we want to make these insights accessible and understandable for humans.
Of course.
So the system needs to translate all that technical jargon into plain English, maybe provide some clear visualizations, and offer contextual information that helps us make sense of the connection.
So it's not just about finding the answer. It's about presenting it in a way that sparks curiosity and deepens our understanding. This is all incredibly impressive. But I'm guessing it takes a lot of careful orchestration to make all these different pieces work together seamlessly. Is that where step 4, orchestration and execution, comes in?
Precisely. Imagine an orchestra with all its different instruments and sections.
Okay.
You need a conductor to bring it all together, to make sure everyone's playing in sync and following the same score.
Right.
Well, in this case, the code has its own conductor, a master function that oversees the entire process from start to finish.
So it's like a grand symphony of code,
Right.
with each function playing its part to create a harmonious whole.
Exactly. This master function is responsible for managing the flow of information, handling errors, and ensuring that the entire process runs smoothly and efficiently.
Okay.
And just like a conductor needs a clear score, the code needs to be well-structured, well-documented, and easily maintainable.
It's amazing how these seemingly simple questions about relationships can lead us down such a fascinating path of discovery. We've gone from translating natural language to navigating these massive knowledge graphs to analyzing these complex connections. And it's all orchestrated by this elegant dance of code. I can't wait to delve even deeper into the specifics of how this all works.
I'm ready when you are. Let's dive into those code snippets and see the magic in action.
Wow, that was a wild ride through the inner workings of knowledge graph technology.
Yeah.
I'm still processing all those intricate details and the amazing possibilities. It feels like we've only scratched the surface.
Oh, we've laid a good foundation. But there's so much more to explore. Remember those intriguing hints about advanced NLP models and user interfaces? Let's dive into those uncharted waters.
I'm ready to take the plunge. Imagine a world where we could interact with knowledge graphs as easily as we chat with a friend. Could you paint us a picture of what that user experience might look like with these advanced NLP models in place?
Okay, imagine this. You're curious about the historical ripples of, say, the printing press.
Okay.
So instead of painstakingly crafting a query, you just ask naturally, how did the printing press influence the Renaissance? And then the NLP model jumps into action.
Cool.
It dissects your question, not just looking for those keywords, but really trying to grasp the deeper meaning and intent behind what you're asking.
So it's not just recognizing words, it's understanding the nuances of human language.
Right.
The way we express ourselves, the questions behind the questions.
Exactly. This advanced NLP model acts like a seasoned scholar, grasping the subtleties of your inquiry. It navigates that knowledge graph, not on this rigid path, but with a real understanding of context and relationships. It fetches the most relevant and insightful connections.
It sounds like we're moving from a keyword-based search to a true conversation with knowledge.
Yeah.
And that opens up a whole new realm of possibilities for education, research, even everyday problem solving, doesn't it?
Absolutely. Imagine students, instead of reading dry textbooks, they could delve into these historical events through interactive explorations, guided by an AI tutor that actually understands their curiosity.
Wow.
Or researchers, they could uncover hidden connections in scientific data, maybe leading to breakthroughs that would otherwise remain obscured. Even businesses could leverage this technology to really analyze market trends and make strategic decisions with a depth of understanding that was never before possible.
It's mind-blowing to think how this could democratize access to knowledge, really empowering everyone to become an explorer in this vast intellectual landscape.
It's exciting.
But let's not get ahead of ourselves. Our sources also mention some practical considerations for actually enhancing this current system. What are some of the key areas for improvement?
Well, one crucial aspect is error handling.
Okay.
In the real world, things don't always go according to plan.
Right.
Imagine the knowledge graph server has a little hiccup, or the query returns some unexpected results. So robust error handling is key. It ensures that the system can gracefully navigate these bumps in the road and provide, helpful feedback to the user instead of just crashing abruptly.
Yeah, that makes sense. We want a system that's reliable and user-friendly, not one that throws a tantrum at the slightest glitch.
Exactly.
So what other improvements did the sources highlight?
You remember that placeholder URL in the code?
Yeah.
Well, that points to a crucial element, like the need for a real user interface, a well-designed UI that acts like a bridge.
Okay.
It connects the complex inner workings of the system with the human user. It makes it intuitive and engaging to interact with this powerful knowledge graph technology.
Now we're talking. I'm envisioning an interface that transforms this technology from a tool into a captivating experience. What kind of features would make this UI truly revolutionary?
Imagine a visually rich interface that actually displays this interconnectedness of knowledge like a dynamic map. Users could zoom in and out to explore different levels of detail, trace the paths of those relationships, and even add their own annotations and insights. This wouldn't just be a search tool, it'd be a platform for collaborative knowledge creation.
I can just picture researchers from different fields coming together on this platform, sharing their discoveries and forging these new connections that could lead to, groundbreaking innovations.
Right.
It's like we're creating a digital renaissance, a vibrant hub for this interconnected thinking and exploration.
I love that.
But with all this information at our fingertips, wouldn't there be a risk of information overload?
That's a valid concern. However, a well-designed UI would also incorporate features that help users navigate all this abundance of information.
Okay.
Intelligent filters, personalized recommendations, intuitive navigation tools. These would empower users to find the most relevant and meaningful connections, ensuring they don't just get lost in that data deluge.
So it's about striking a balance between breadth and depth, between exploration and focus. We want a system that encourages curiosity while also providing those tools to make sense of this complex web of knowledge.
Exactly.
It's amazing to think we've come this far. We really dove deep into the mechanics of knowledge graphs. We saw how they take raw data and turn it into this incredible tapestry of interconnected insights.
Yeah.
But as we stand here kind of on the edge of this knowledge revolution, I can't help but think, what are the bigger implications of all this? How could this technology actually change how we learn, think, and even make decisions?
That question takes us beyond just the technical stuff and into the heart of human understanding.
Yeah.
You think about it, traditionally, knowledge has always been so fragmented, right? Scattered across books, articles, databases, each one kind of a silo.
Right.
But what knowledge graphs offer us is a way to actually bridge those divides.
Okay.
They help us see the connections that were hidden before.
It's like we're piecing together this giant jigsaw puzzle of knowledge. Each piece is a concept. And those connections reveal the bigger picture, which is far more intricate and nuanced than we could have ever imagined.
Exactly. And that interconnectedness, that has profound implications for how we approach problem solving.
In what way?
Well, imagine trying to tackle a complex challenge, but instead of just focusing on one area, you could draw insights from tons of different fields. You would start seeing connections that most people would miss.
Okay.
It's not just about finding answers anymore. It's about asking better questions.
Yeah.
Questions that go beyond traditional boundaries.
It's like having a superpower. The ability to see the world through this multidimensional lens, spotting patterns and opportunities that would otherwise remain invisible.
I like that.
But, with great power comes great responsibility, right?
Of course.
What are some of the ethical things we need to think about as this technology becomes more and more powerful?
That's such a crucial point.
Yeah.
You know, just like a map can be used to navigate a city or even to plan a heist, knowledge graphs, they can be used for good or for bad.
Right.
It's so important that we develop ethical frameworks,
Yeah.
make sure the data is accurate, and teach people how to think critically.
Okay.
We need to empower users to actually tell fact from fiction, bias from objectivity.
So it's not just about the technology itself, it's about how we use it, how we shape it, and how we make sure it serves humanity's best interests.
Exactly. And you know, we can't forget that knowledge isn't this static thing. It's a dynamic process of exploration, questioning, and refinement.
Right.
Knowledge graphs are powerful tools, but they should never replace human judgment, creativity, and critical thinking.
It seems like we've come full circle.
Yeah.
We started out exploring the mechanics of knowledge graphs,
Uh-huh.
and we ended up talking about the very nature of knowledge itself. What a journey.
It really has been a fascinating exploration, and I really hope our listeners have a deeper understanding of the potential of this technology.
Me too.
I think we're truly on the verge of a knowledge revolution, and it's up to all of us to guide it, to make sure it leads to a more informed, insightful, and interconnected world.
Couldn't have said it better myself. Thank you for joining us on this deep dive. Keep exploring, keep asking those tough questions, and most importantly, keep connecting those dots. Who knows what incredible discoveries are waiting just around the corner?